So now we're getting into a different type of a trigonometric equation called a multivariable trigonometric equation. You can see here, instead of tangent of omega, or tangent of x, if you'd rather think of it that way, I have tangent of 3x. And what do we do with that 3 times the variable in there? Well, you might be thinking, oh, it's no problem. I'll just get the answer for 3 omega and then divide it by 3. And that's basically what we do. There is one additional little piece we have to be aware of, and that has to do with the cyclical nature of trig equations. I want to draw your attention to this part right here, where it says the interval 0 to 2 pi. Well, what's over the interval? It's omega. Omega is over the interval 0 to 2 pi. So if I were to write that out, it would look like this. Okay, 0 greater than or equal to 0, this is omega, and less than 2 pi. Okay, those are the solutions we want. But we're talking about 3 omega, not just regular omega. So that means it's going to be less than 6 pi and greater than 0. So instead of just figuring out what solutions we have on the unit circle for 3 omega, we need 3 times around the unit circle. That means we're going to have 3 times as many solutions as normal. So I'm going to take that idea, let's move this guy over here, and let's start with tangent 3 omega equals radical 3 over 3. And you may be thinking of radical 3 over 3 differently. A lot of people prefer to think of it as 1 over radical 3. That's fine. Either one works. So where does the tangent of some angle equal 1 over radical 3? Well, let's make a unit circle here. Okay, here's my unit circle. And remember, 1 over radical 3, we've got this perfect diagonal right here. And right here, those are the 45-degree lines. 1 over radical 3 is like one of these guys. Okay. So these are the positives right here. That's 1 over radical 3, 1 over radical 3. This is tangent that I'm talking about here. And what angles are those? Well, in radians, that's what this is in. Okay, we're not doing degrees at the moment, we're doing radians. This is going to be 3 omega equals pi over 6, and that other one is 7 pi over 6. And now's the part where we have to go around the circle multiple times, okay? This is a 3 times around problem. Okay, we're going around the circle 3 times here. So this is also equal to, let's see, 7 pi over 6, that's going to be, I'm adding 2 pi each time. Or in other words, I'm adding 12 pi over 6. This would be 19 pi over 6. And add another 12 pi, and we get 25 pi over 6. And let's see, 12, 31 pi over 6, I think. If I'm not doing my math wrong, there's all our angles. And now what remains is to divide everything by 3. And then we'll be done. So that means omega, hold still. That means omega equals pi over 18, right? We're just dividing pi over 6 by 3. 7 pi over 18. 13 pi over 18. And so on. We've got 19 pi over 18, 25 pi over 18, and 31 pi over 18. Now, there's nothing to simplify here. If you did see something to simplify, of course you can. I'm going to mark you correct on this problem, regardless of whether you simplify a fraction or not. The important thing to me is that you know how to deal with trigonometry, not necessarily the fractions, the radical signs, and all that. So just get the values right, whether or not they're simplified. Now, I also have on here an example of secant of 3 omega equals 2. Well, this has to be treated a little bit differently. Basically the same idea, but there is one gimmick here in that I don't simply know what the secant values are in a unit circle, but I do know that secant is equal to 1 over cosine, right? That's our reciprocal identity. So that means cosine of 3 omega equals, well, flip 2 upside down, we get 1/2. Okay, so where does cosine equal 1/2 on the unit circle? If we have a unit circle right here, that's going to be, let's see, cosine is the x values. Okay, so that's going to be values like right here and right here. See, they're equal to 1/2. So this is, what do we have here? This is 3 omega equals, that looks like pi over 3 and 5 pi over 3. But remember, because we're going around the circle 1, 2, 3 times, this is actually going to include more angles. It's also going to include 7 pi over 3. You know what? I'll keep these things lined up so you can see how these work. 7 pi over 3 right there, and then 11 pi over 3, right? Each time around, I'm adding 6 pi over 3. So this is now 13 pi over 3 and 17 pi over 3, I think. Okay, and now all we do is we divide each of these by 3. Okay, so we're going to get omega equals pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Seems like a giant pain in the neck, I know, but, you know, welcome to the horrible, messed up world of multi-angle equations. That's just what you have to deal with. I promise I'm not going to ask you anything that goes higher than 3 omega. Usually I just focus on 2 omega or 3 omega to see if you get the idea. We're not going to do 4 or 5 omega. That's just crazy.